The binomial distribution is very slick and powerful, but we need to make sure that we're using it only under the right conditions and we have the right language to describe what we're doing. In order to determine if a count has a binomial distribution, first thing we need to make sure is that the probability for success cannot change at any time. And along with that, each trial is independent. So what I mean by that is if you're flipping a coin, the first coin flip has a 50% chance of being heads. The second coin flip has a 50% chance of being heads, and so does every coin flip afterwards. So that would be the probability for success never changing. If you define success as getting a heads, then the probability of getting a heads never ever changes. So that part's good. The part about trials being independent is related to that. And what it means there is the first flip doesn't affect the second flip. So they're completely independent. Now, free throw shooting is actually kind of an interesting example of something that's not truly meeting this condition, but it might be close enough to get away with it. So the probability of making one free throw versus the next might not be truly independent. It might actually change a little bit. Because if you miss one, perhaps you get in a slightly bad mood, or you're just not feeling on your game such that you would be more likely than to miss the next shot. Whereas if you make one, you might get in more of a rhythm and therefore be more likely to continue making it. So just be aware that sometimes we'll use the binomial distribution when we're pretty close but not perfect on this first condition about probability for success not ever changing. Second thing, the result has to be a success or failure. There's no other options. Basically, you have two choices. If you said, what is your favorite team? The Packers, the Vikings, or the Bears? That would not allow you to use the binomial distribution. You would instead have to rephrase your question as something like, is your favorite team the Vikings? Yes or no? Anything that has only two options. Who are you going to vote for president? The Democrat or the Republican? Two options. Because then you can artificially call one of them success, and I'm even going to put this in quotes, or failure. Because they're just made up terms. They're just labels that you slap on something. If in the examples we did earlier, Batman was considered a success because it was the result I was looking for, and Iron Man was considered a failure. That's a completely arbitrary distinction. So you just have to know that there's only two options, and you'll call one success and call one failure. Last condition, number of attempts to count must be determined before you start. So if you're going to look at something and consider a binomial distribution, you need to decide how many trials before you start attempting, or how many people to sample. So in the case of number of trials, let's say free throws, I'm going to take 10 free throws right now, and let's see how many I make. Not, oh, I'm going to shoot until I miss. That would be different. That would not meet this condition. Whereas I'm going to take 10 free throws, and we'll see how many I can do, how many I can make. That would be setting the number of attempts or number of trials before we started. Now we're going to connect the binomial distribution back to some of the sampling stuff we've done earlier. What we originally called the probability for success not changing is saying that the population has some value that is some set value that we want to find out. In the case of the examples we've been looking at, we said that the population has 62.5% of the people who prefer Batman. That's the set proportion. It doesn't change. The class said this is its value, and no one's allowed to change their vote. So we're stuck with that number no matter what. Our goal in whenever we're doing a sample is to try to figure out what this actual value is that represents the whole population, even though we don't know it. We're only going to ask a few people, and we're going to try to guess what that value is. Second thing is something must be success or failure, and nothing in between. As I kind of alluded to earlier, you need to come up with questions that have only two options, such as yes or no or true or false. Third thing is the number of attempts you count must be determined before you start. And in this case, it's kind of a condition that doesn't really apply to how we're going to approach a sampling situation, but just your number of trials, n, is the same as your sample size. So if I am going to take a sample of 5 people, that would be the number of attempts or trials that I'm going to do. I'm going to ask 5 people, Batman or Iron Man. I'm not going to keep asking people until I get the result I want, for example. So that's what makes it binomial. Last thing is just making sure we know what n and p are. These are two terms that are going to come up a lot. N is always the number of trials that you're going to do, the number of attempts you're going to have. I'm going to shoot 10 free throws, n is equal to 10. P is the probability of success. If you are a 30% free throw shooter, then P is 0.3. If a coin has a 50% chance of being heads, P is 0.5. Such like that. And you always write P as a decimal, not as a percent.